In the last section, we took a look at the game Plinko. Remember, our goal here is to somehow drop a ball at some point on the board and predict which bucket is going to fall into. So in this section, we're going to start walking through the same series of steps that we just walked through a couple of minutes ago. The first thing we need to do is somehow identify the data that is relevant to the problem that we are trying to solve. Now, I think that there's two pieces of data that are probably pretty evident or obvious from the get-go, but there might be one or two others that are a little bit less obvious. So the first thing that is probably very relevant to the problem we're trying to solve is to somehow record where we are dropping this ball at. You'll notice that on the top right-hand side of this little board, I have a drop position counter. That drop position is measuring the number of pixels from the top left-hand side, or the very left-hand side, all the way over to the drop position. So all the way over here at the very far left is 0 pixels, and then as we start to go right, we increment that drop position by 1 for every pixel over that we move. So if I click right here, I am dropping this ball at drop position 555, or essentially 555 pixels over from the left-hand side. And that's probably a very obvious piece of data that we're going to want to record anytime that we drop a ball. The other piece of probably obvious data that we would want to record is which bucket the ball falls into. So did it fall into bucket 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10? Now again, those are probably two obvious pieces of data that we would want to record. But I have a quick question for you. Do you think that there might be any other pieces of data inside this application that we might want to record as well? Other pieces of data that affect where a ball falls or which bucket the ball falls into? Well, if you look really closely underneath this chart, you'll see these two little forms down here. One that says range of ball bounciness, and the other that says range of ball size. So these are two little inputs that will control exactly how bouncy the ball is and how large the ball is as well. The other thing to notice here is that these are ranges of values. So I have a start range of 0.5 and an end of 0.55. That means that my bounciness factor, essentially, for lack of a better term, will be somewhere randomly between 0.5 and 0.55. I can change the start value to something like, say, 1, and then the end value to something like 0.1. Now I have a much less bouncy ball. So if I now click on this chart up here, you'll notice that the ball is really not bouncing at all. And as you might guess, that's probably going to affect exactly how, or excuse me, it's going to impact exactly which bucket the ball ends up falling into. So in addition to the drop position, I think that the bounciness of the ball is going to be something very relevant to trying to predict which bucket the ball goes into. One other thing I want to show you very quickly is that I could bump up the start to 0.9 and the end to 1. And now we're going to have a very bouncy ball. And so if I drop these now, you'll see that they're bouncing all over the place, and they might end up going very far from where they started. Okay, so now the other one is the range of the ball size. Right now it's fixed at 16 pixels, or essentially 16 pixels wide. I could very easily change this as well. So let's say we have 30 to 30. Now if I drop a ball, it's much larger than it was before. And again, as you might guess, I would probably argue that the ball size is going to affect which bucket it eventually falls into. So in total, I think that we're going to have 3 different features and 1 label. I think that we need to somehow record a drop position, the bounciness of the ball, and the ball size. And I think that any time that we change one of these features, we're going to be somehow affecting or changing which bucket the ball is going to land into. So we're going to have 3 features, and I think we're going to have the single label of which bucket a ball lands in. All right, so let's take a quick pause right here. When we come back to the next section, we're going to start to think about assembling a set of data related to this problem. So quick pause, and I'll see you in just a minute.